One click, some magic behind the scenes, and then you instantly get a public server address so your friends can join. This would be the dream of setting up your own Minecraft or any type of game server. But the current reality usually looks more like this. Because the hard part is rarely launching the server, the hard part is making it reachable from the internet. So in this video we are building an app that tries to make the dream real. And it actually worked, until I sent it to friends and the Windows Defender basically went, absolutely not. So this isn't a copy my code line by line tutorial, it's a build story. What I tried, what worked, what broke, and why shipping a one-click server app can accidentally look exactly like malware. By the end, you will understand what's actually happening when someone hosts a server and how you can wrap it all in one simple desktop app that a 7 or 70-year-old crafter can use. Alright, let's build it. After almost a decade of Minecraft abstinence, I wanted to play around again with a few friends on a small survival server, and somehow expected that things might have changed. But I was immediately back in the golden age of Hamachi, port forwarding tutorials, router admin pages, and interfaces that looked like they were designed by the router itself. And yes, these are solutions that can work, obviously, but most of them are either watch this 25-minute video or install this tool that assumes you enjoy networking. But most people don't, and also I just wanted to click a button and play the game. And yes, I get it that Mojang has started to sell game hosting for hefty prices directly in the game, so simple self-hosting is not exactly on the top of their priorities. But yeah, if they don't do it, then obviously it's up to us. So let's be clear on what we intend to achieve. A UI that could be handled by a 7 or 70-year-old crafter alike, doesn't overwhelm with settings but comes with sensible presets, abstracts away the complete technical setup, and by default directly provides a public server address so friends from anywhere can join. So let's get straight to it and tackle the hardest technical challenge first. Okay, just kidding, let's draft a nice interface. The upside is, if you start with the technical parts, you start thinking in technical constraints, make compromises too early and lose track of the theoretical optimal outcome. So I started with a sketch. UX people call it low fidelity, which is a fancy term for it looks like sketch by someone in kindergarten. Once satisfied, I recreated those boxes in greater detail in Figma, so it became something that could actually be built. But more importantly, by connecting buttons with screens, it can somewhat resemble the intended experience. And with this, I did the most scientific test available. I gave the prototype to friends somewhat familiar with Minecraft and watched them suffer. Just providing the instruction, you want to play Minecraft with a friend? Use this app to set up a server so they can join you. And then I shut up. They think out loud, I watch where they click, where they hesitate, and where they succeed. And surprisingly, it worked. People found the right buttons, understood the flow, and nobody asked what is a port. So the UI survived, but now I had to make it real. I built the app with Electron and React, but don't worry, you don't need to know exactly what those are. The easiest way to think about it is, the interface is basically a website, with buttons, menus and animations, stuff browsers are great at. And Electron is a wrapper that takes that website and turns it into a real desktop app you can install on Windows or Mac. The cool part is, even though the UI is built like a web page, the app can still do real computer stuff behind the scenes. It can download files, create folders, edit config files, start other programs and read system info like CPU or RAM, which is exactly what we need for a one-click server setup. So yes, it's kind of like a browser wearing a desktop app costume. And honestly, that's not unusual anymore. Discord, Spotify, Figma, VS Code are all basically Chrome browsers with a different logo and no tabs. The downside is that Electron apps can be a bit heavier because they all ship with a mini Chrome-like engine inside just to display the interface. But for an MVP, it's a trade-off I happily take. I can build and iterate fast, and the user experience matters more than spiritual purity. So I recreated the screens and flow from the Figma prototype, and it looked great. It also did absolutely nothing. So it was time to add the machinery and overcome the two core challenges of hosting a server at home. The first one is running the server software, mostly annoying but easily solvable. The second challenge is making it reachable from the internet, and this is where everyone's weekend goes to die. For Minecraft, the server setup is mostly straightforward. We download the official server file, agree to the terms of use, and run the jar. All steps the app can execute without us needing to do anything manually. Once this is done, the server creates a world on first launch, generates all missing files, and our server is already running. However, in some cases there might still be an error if a recent version of Java is not installed. And yeah, we don't want to require users to search for the right version, download it, install it, and deal with all that. So the app checks for a suitable Java version, and if it doesn't find one, it automatically downloads a compact version of it into the app folder and uses that to launch the server. The user doesn't even have to think about it. This process was shockingly smooth to create, and for the users it's already just click create, wait a few seconds, and you get a locally running Minecraft server, which is great, but still useless because your friends can't join yet. And this is where the main challenge comes in. Your router or Wi-Fi box blocks external inbound connections, such as friends trying to join your server by default. A good protection, but somewhat in conflict with playing together on your own server. So time for challenge 2. The classic solution to this is so-called port forwarding. Ports can be understood as doors on your router. By default, there's a firewall in front of those doors, so when someone from the internet knocks, the router usually just says nope and ignores it. Think of your router like the bouncer at a private house party. If a random stranger shows up and says, "Let me in, I'm here for the Minecraft server," the bouncer is like, "I don't know you." That is inbound traffic and it's blocked by default. Port forwarding is basically you giving the bouncer a very specific instruction. If someone knocks on this door, for example the Minecraft door, let them in and send them straight to this device inside the house. In other words, traffic arriving at that specific port gets forwarded directly to your local PC where the Minecraft server is actually running. And voila, friends from outside can join. But this approach has 3 minor issues. Not everyone has router access, not everyone wants to open ports, and router interfaces vary so wildly that every tutorial is wrong in a unique way. And more importantly for us, we can't automate it, because our app can't and also shouldn't have the power to change anything on your router. So it would again require tutorials and manual work, and that very much defeats our one-click no tutorial user experience. But there's a second option. Instead of trying to convince your router to open a door, you use a public server on the internet as a front entrance and you connect to it from home. That public server is called a VPS, basically a tiny rented computer in a data center. And the key advantage isn't just that it has a public address, but that it's under our control. We set it up once and then everyone can use it as a shared entry point. So users don't have to change anything on their router. And from your friend's perspective, it even looks like the server is running on that VPS. They just connect to one public address and never have to know it's actually on your PC. Because the trick is the following. Your router blocks strangers from walking in, but it has no problem with you walking out. If you start a connection from your PC to the outside world, your router allows it. And replies to that connection are allowed too, because it's part of the conversation you initiated. A tunnel uses that intentionally. When you click Create Server, the app opens a permanent outgoing connection from your PC to the VPS, like keeping a phone call running. Now your friends don't try to knock on your home router anymore, they connect to the VPS, because that server is public and can accept visitors. And the VPS simply forwards everything through that already open phone call back to your PC. So your router never has to let a stranger in through the front door. It only ever sees traffic on a connection you initiated, which is why tunneling magically works, even when port forwarding is blocked. So I rented a tiny VPS, the cheapest little server I could find, opened the firewall on that and made it the public endpoint. Players connect to the VPS forwards traffic through a tunnel to the server running on your PC, and your home network stays closed. Given the constraints, it's the only option that makes sense, so I started experimenting. For the tunnel I found an open source project called FRP, so I was glad I wouldn't need to build something myself and happily bundled FRP into the app. It was premature joy, but more on that later. Now when the user clicks Create Server, the app starts Minecraft locally, starts FRP, connects the tunnel to the VPS where the counterpart program is running and forwards the traffic, and players can connect using the VPS IP and the chosen port or door. A functional but ugly solution. Hey, join whatever IP and whatever port. That's not an invitation. Fortunately, there's a nice alternative, because Minecraft supports so-called SRV records, which are a smart way to map domains like myserver.cloudecho.com to a specific IP and port combination, the door on the VPS behind which the tunnel is running. Obviously, I need to be the owner of this domain first, so I bought cloudecho.com. The game will automatically check whether such a record exists when players connect with a certain domain or subdomain, and if so, it will connect with the IP and port written there. So I added that when a user creates a server, I assign them an available port on the VPS, create a unique subdomain by randomly combining 2 words from a list of typical Minecraft terms, for example lavapig.cloudecho.com, create the corresponding SRV record, so lavapic.cloudecho.com points at the right door on my VPS, and then show this domain to the user once everything is completed. And it worked, exactly like I wanted. You click create server, a short loading screen shows up, then you get a domain. You send it to your friend, they join from anywhere, and it feels like magic. So we are done, right? I compiled it into one app, sent it to friends to test, and yeah. The antivirus programs were not happy, to say the least. The moment the app tries to start the tunnel binary FRP, Windows Defender gets very interested. From an antivirus perspective, this app downloads executables, writes config files, launches processes, and opens network tunnel, which is an extremely normal thing to do for malware. So even though the user experience is smooth in theory, in practice the app gets treated like a Trojan the second it touches a normal machine. After a bit of research, it was clear that even though FRP was open source and maintained by a great community, the program had apparently been misused in the past by bad actors, so it was pretty much blacklisted. This was also part of the reason why submitting the app to the Microsoft Store was denied again and again. So I looked for alternatives, and looked, and okay, I do it myself. But to understand exactly what this means, we need to have a look at how game servers communicate. In the end, it's just a stream of little messages going back and forth. Where is a player? What got clicked? Who got hit? What changed in the world? And there are two main ways to send these messages: TCP and UDP. Minecraft is a nice example here. The Java edition uses TCP, while Bedrock relies heavily on UDP. TCP is like a walkie-talkie conversation with receipts. After every message, the other side has to confirm. If they don't, you resend, and everything is kept in the correct order. Super reliable, but slower, because you're constantly doing send, confirm, send, and so on. Meanwhile, UDP is like broadcasting updates over a loudspeaker. You just keep sending them. Some might get missed, some might arrive out of order, but nobody stops the game to ask for resend. It sounds worse, but for fast games, it's often better. If a single player moved one step, packet gets lost. You don't want the entire game to freeze and wait for it. You'd rather just get the next update a split second later and keep everything feeling smooth. That's why many games use a mix. TCP for things where correctness matters, like logging in, loading data, or is the server online, and UDP for the real-time gameplay where speed matters most. And for our tunneling solution, that means one thing. It can't just forward the walkie-talkie traffic, it also has to carry the loudspeaker traffic. So I built my own tunnel, a small component inside the app and a matching part running on the VPS. When you start a server, they establish a secure tunnel and the app tells the VPS which protocols to expect: TCP, UDP or both. From there, the job is pretty straightforward. Packets arrive on the VPS, get forwarded through the tunnel to the correct local server, and the replies go back the same way to the right players. It's basically a middleman, like a mailroom. While I was initially not amused by the need to build my own solution, it turned out to be a surprisingly good choice, because it let me build in security features and proper support for multiple servers running through the same VPS, which FRP simply wasn't designed for. For example, I can ensure that tunnels with a remote port can only be set up if a user was actually assigned that port. I can rate limit weird connection patterns, cap the number of connections per minute, and reject packet sizes that look nothing like normal gameplay. And overall, I can build this in a way that avoids the app landing on the same kind of blacklists as FRP. Let me be honest, the first time I joined a server remotely after working on this for a while, I had a little eureka moment. I just jumped around in the newly created world without any purpose. Okay, I still do it when I create a new one. But yeah, this self-made tunneling solution worked, and both TCP and UDP traffic were successfully forwarded. Most importantly, however, it now passed the Microsoft Store review without any issues. So where's the catch now? Can you really just set up a server with it for free in one click? Honestly, the VPS cost me barely anything. And as long as there aren't thousands of servers running, and I'm not maintaining setup scripts for 10 different games, it's totally manageable. I also added a 20GB per month bandwidth limit for now, which is more than enough for regular sessions with friends and helps prevent abuse while keeping the VPS load low. But yeah, if there's demand for more, let me know. If you want to try the app, check it out and tell me what feature I should build next.